And we begin again. This is, what, part 3, part 4, something like that. So, start with question 16. Find the dot product of the two vectors. So, v is negative 7i minus 3j, and u is, no, w. Oh my gosh, they changed it on us. W is 9 minus 21j. 9i minus 21j. And the i's and j's don't really matter, you just convert it back to a component form. Negative 7 minus 3, negative 7 minus 3, and 9, negative 21. And you do the dot product, which is you multiply the x's together, and you multiply the y's together, and then you take the sum of the two. So negative 7 times 9 is negative 63, and negative 3 times negative 21 is positive 63. So negative 63 plus 63 is 0. That's the dot product. A quick note, which was just so you can observe it, as we'll be using in the next few problems probably, that if the dot product of two vectors is 0, then the vectors can be considered orthogonal. Which really just means that the vectors, they form a right angle. If you put the two vectors together, they don't necessarily have to touch, but if they were to continue on forever, they would form a right angle somewhere. And that's what happens if the dot product is 0. 17. And now we're going to use dot product properties to evaluate something. Fun. So, u is negative 4, negative 3. V is negative 1, comma 4. And W is negative 1, 1. Right. And they want you to find U times V dot, no, V plus W. So U times U and the dot product of V plus W. And there's a bunch of ways to evaluate this, and there's like the specified way, that's in the notes, but you can evaluate whichever way you want. And so you put U in there, negative 4, negative 3, and you want the dot product of that, and V plus W. So V plus W, negative 1, you just add the two together, x and x and y. Negative 1 minus 1 is negative 2, negative 2, and then 1 plus 4 is 5, and then you do the dot product of the two, which means x times x plus y times y. Negative 2 times negative 4 is 8. Negative 3 times 5 is negative 15. And you add those two, 8 minus 15 is negative 7. And that is your evaluated expression. Look at that, we're rolling on this one. 18. Angle between the two vectors. And express in radians. They say radians, so look at that, my handwriting is degenerated over the last 4 videos. Anyway, radians, observe that. So U equals 6i minus 8j. V is 5i plus 3j. Right. Okay. Then here's a nifty little theorem that says the angle between two vectors is equal to the dot product over the product of the magnitudes. So U and the dot product of V, the dot product of the two, over the magnitudes multiply together. So magnitude of U times magnitude of V. And it's a bit confusing, but another thing you're going to have to memorize. Sorry for that. So just plug the numbers in. 6, negative 8, and 5, 3. Let's do this off to the side. Magnitude of U, the square root of 36 plus 64. Look at that, it's 100. Square root of 100 is 10. So 10 times, here we go, 25 plus 9 is, what, 34. if you do the dot product, you get 6 times 5 is 30, and then 8 times 3 is 24, add the 2, or negative 24, negative 8, and positive 3, 9 is 24, over the multiplication, 10 square root of 34, ow, which is 6 over 10 square root of 34, which is, and then you want to plug that into your calculator so you can get it in radians. Make sure you change it to rad in the mode, and you get 0.103 radians. Hopefully you see that, and that's your radians, and they say round to the nearest tenth, and 0.03 doesn't do anything to affect that, so 0.1. Okay, moving on to question 9. Oh, not that side. Okay, determine if the two vectors 2i plus 2j and negative 6i minus 4j are orthogonal, parallel, or neither. So you could do the whole formula from the other side, which said that the dot product over the multiplication of the magnitudes to find the exact angle between the two. Or you could take a little shortcut which says that if the dot product is 0, then that means that they're orthogonal. If the dot product is 1 or negative 1 maybe, it's parallel. And if it's anything else, then it's neither. So dot product time. 2 times negative 6 is negative 12. 2 times 4 is negative 8, which is negative 20. And that falls in the anything else category, which means they are neither. If you want to check this, you can do this divided by the product of the magnitudes, which is square root of 8, then 36 and 16. What's 36 and 16? Yeah, it's 40, 52. 52, and that's definitely not going to equal 90 or 180, so yeah. 20! Making good time in this video. 20. So identify the decomposition of u into the sum of two orthogonal vectors, one of which is the projection of u onto v. So that sounds really complicated, but isn't too bad if we break it down. So if we say the u is the sum of two vectors, we're going to call those w1 plus w2. That's the u broken down into the sum of two vectors. And one of them, we're going to call that w1 is equal to the projection of u onto v. Okay, so, and they give you the two vectors where u is, or u are, if that's correct grammar. It's a math joke, okay. U is 4, 2, and v is 6, negative 2. And yeah, so projection of u onto v. So the number that's here, or the vector that's here, is going to be projected onto this one. There's a nice little diagram that goes along with that, but I'm not going to draw that. Sorry. So the projection of u onto v, so it's this onto this, okay? Hopefully you can see that, is going to be, what's it going to be now? Oh, sorry. Okay, so it's the dot product over the magnitude of what you're projecting onto squared times what you're projecting onto. So if we're going to write this out, it equals u dot product v over v magnitude, this is magnitude of v, squared times the vector v. That's a weird way of writing it. But so dot product, 4 times 6 is 24, 2 and negative 2 is negative 4, over vector magnitude of v is the square root of 36 plus 4 is square root of 40. And then because it's squared, you really just take to get rid of the square root over 40. Right, wrong, that's right. Times the vector 6, negative 2. And this is to get a projection of v, which is actually equal to W1. So W1 is equal to this. So 6 over 40, which is 3 over 20, times 6, negative 2. No, I did that wrong. 24 minus 4 is 20, sorry. There's a mistake here. 24 minus 4 is 20 over 40, which is 1 half. 1 half of this, you just multiply across, is 3, negative 1. That's W1. So W1 equals 3, negative 1. To find W2, you can go back to this formula up here. So W2 is going to be, say, move this one to the other side, U minus V, U minus W1. Okay, W2 is U minus W1, and you already have W1, and you already have U, so U is 4, 2, you are 4, 2, minus W1, which is 3, negative 1. 4 minus 3 is 1, 2 minus minus 1, or 2 plus 1 is 3. So W2 equals 1, 3. So the first one, which you're looking for, is the projection of U onto V, which is W1, which is equal to 3, negative 1. Then they're looking for the orthogonal vector, which is going to be W2, which is 1, 3. And we look to our trusty answer choices, and we see that answer choice B says U is equal to 3, negative 1, comma, or plus 1, 3. And those are your 3, negative 1, plus 1, 3. Maybe we can squeeze one more problem into this video. Okay, same idea on this next problem. V is 34i minus 34j, and U is 3i plus 5j. And this time, though, they reverse it, and they want to say vector component of V onto orthogonal to U. So this time we're going to reverse it, so projection of V onto U. And that's going to be equal to W1. And this time V equals W1 plus W2. And you just change the variables on it. Just be a little careful for that. And you do the dot product stay the same, which is 34 times 3 minus 5 times 34 over, this time it's going to be U squared. So the magnitude of U is square root of 9 plus 25 is square root of 34. Square root of 34. And if you want to square that, you get back to 34 over 34 times the vector U is 3, 5. So we go through that, and you get this top is going to end up equaling negative 68, and the bottom is the denominator of this fraction is 34 times 3, 5, and that's negative 2 over 1. So negative 2 times 3, 5 produces negative 6, negative 10. That is W1. That's the projection of U onto V. No, V onto U. Projection of V onto U is negative 6, negative 10. So then W2, W1 is that, and W2 is going to be V plus that. So 34 minus 6, comma, negative 34 minus 10. Is that right? No, we have to subtract them. Did I subtract? I'm losing my mind. So you actually add these two, and you have to add that. So you get an answer of 40, comma, negative 24. And that's your W2, and W1 is right there. And those are your two